The health department's call for bids to import, store and distribute COVID-19 vaccines at very cold temperatures had led to one company in South Africa developing a unique solution. Natural gas producer Renergen says it'll start producing ultra-cold mobile freezers with a temperature range of minus 150 degrees Celsius to about 8 degrees. Now, this, of course, can be used to store vaccines for up to a month, we're told. This is without the need for fixed power supply, which is important given our troubles. For more on this, let's bring in Stefano Marani, who's CEO of Renergen. Stefani, thanks very much for your time and welcome to the program. If my knowledge around physics is half decent, I understand helium to actually exist as a gas. Part of the solution needs for helium to exist as a liquid. Again, that would need energy to get it right. Take us through the requirements energy-wise to at least get to that stage.
So you're absolutely right. Most elements exist in three phases, either solid, liquid, or gas. And you can just think of water. It's either ice when it's frozen, or it's liquid, or you put it in the kettle and it becomes gas. And its physical state is really just a representation of the amount of energy that it has. Now, what we've designed over here is a case with space age insulation in it and a series of patented heat exchangers inside it that will take either helium or nitrogen, depending on what you want to use the case for. And it'll take the liquid form of these gases. It'll turn it into a gas. And when the gas is at exactly the right temperature, it'll then be deployed to transfer the temperature to where the vaccines are stored. And that gives this case the ability to give you precise temperature control, as opposed to literally just sticking a box full of dry ice into a cooler box and moving it that way.
Right. It's very difficult for people to connect how we can have cold temperatures without having electricity. And let's not get into the physics and the science of it, but just broadly speaking, how would you explain that? Because that's essentially what your company is providing as a solution here.
So liquid helium exists as a liquid at minus 269 degrees Celsius. And when it turns into a gas, that's the temperature at which it boils. So that's like 100, that's like water in a kettle boiling at 100. When it turns into a gas, it then has a very, very long way to go from, call it minus 268 all the way up to minus 70 where the vaccines are kept. And all of that energy that's released, we release that energy into the case. And that energy is basically stored in the case in a way for deployment to keep it cold. So yes, if you think about a common fridge requires electricity. But all that a fridge is, if you really boil it down, is actually just a liquid that's boiling off. There's a thing called a refrigerant. I'm sure that you're aware when a car has to go for a gas recon for its air conditioner, when the air conditioner breaks. All that's happening is they're putting a liquid in there, and that liquid then boils and it releases energy, and that releases cold into your car and keeps you nice and cool in a hot day. It's the exact same thing over here. The only difference is that instead of recycling that liquid, so in other words, turning it from liquid to gas to liquid again using a compressor, what we're doing is that we've created a storage vessel to hold the liquid and only use the liquid when needed. And then the rest of the gas is vented into the atmosphere. So you don't need electricity because you're not recycling it.
Fascinating. This obviously doesn't last forever. How much longer does this boiling process, as you explain it, last? And how does that present interesting challenges for ways through which we can store something like the Pfizer vaccine, which we now know needs to be stored at minus 150 degrees Celsius or something like that?
This case has been designed for last mile deployment. I think if you start to work through the mechanics of the vaccine to vaccination logistics, it's quite formidable. Every single dose takes about 15 minutes of a healthcare worker's time. That means that if you've got, say, 1,000 doses of a vaccine on you, you're going to need 15,000 minutes worth of people's time to be able to deploy those vaccines. So it's not enough to just have a case that's going to bring you 1,000 doses to a rural area. that's not going to work. You need a lot of healthcare workers to be able to deploy it within a short space of time. The current solution and the current technology around the world only gives you 3 days. What we've given is the ability to hold it for 30 days. And that therefore allows you more time to adequately dish out the vaccines without the risk of them spoiling and going bad. And that's the point over here. I believe the World Health Organization estimated that somewhere in the region of 40% of all world's vaccines go wasted. And I'm not talking about COVID. I'm talking about mumps, measles, smallpox, polio. These are still very real diseases in Africa. And these diseases are really, the World Health Organization and UNICEF are really struggling to deploy vaccines in the last mile in these jurisdictions. And this is a case that will help with that entire vaccination program too.
And given that, I imagine that's why you've been quoted as saying in some reports that there's actually already demand for this prototype cold chain storage unit that you're offering. At what cost, though?
So, look, it's not a cheap freezer, but it's not more expensive than traditional freezers. The benefit that we have is that you can actually move this one around without electricity, and so that's a major advantage. If you look at just the plain operating cost of this unit, you're looking at an operating cost of somewhere in the region of about 7 to 10 rand cents per dose per day, which, if you quantify that against the potential life that you save from a spoiled vaccine that didn't get into someone's arm, that's an insignificant cost.
Absolutely. Interesting perspective there. Thanks very much for your time. We're watching the space to see how this unfolds. It certainly is an interesting solution to watch out for. Really appreciate your coming on. Stefano Marani is the CEO of Renergen. That's a company in South Africa that's developed this unique solution to try and create ultra cold conditions, so to speak, so that we can store things like a Pfizer vaccine that we know can't be stored in a regular refrigerator. So we watch that space quite closely for you.